Hello everyone, welcome back to the second video on the topic interest. In the first video, we discussed what exactly is simple interest, what is compound interest. We discussed the definition, we understood the two terms, we understood the formulas that are to be used in both the cases. Then we also solved a couple of questions so that we are able to bridge the gap between the theory part and the question part. Okay, because that's where the problem actually comes. We understood both the things in details. We'll be discussing them in this video also, no denying on that part. But if this is the first video on interest that you are watching, then I would request you to please go through the first video on interest, because in that video I have discussed compound interest in extreme detail. Okay, I've explained what in depth what exactly is compound interest, how is it similar to simple interest, and how is it different from simple interest. Okay, all right, so without wasting time further, let's go back and discuss the more theory related to compound interest. Now, in the previous video, we discussed what exactly is compound interest and how do we calculate compound interest and the amount. We also discussed that whenever you talk about a question pertaining to compound interest, you will always come across either of the two words, that is compounded or compounding. Okay. Now, moving on further, when you talk about this term compound interest, what happens sometimes is that you may get a question something like this. Like, let me explain you the theory part with the help of an example, because then it's going to be more relatable. So it's the question goes something like this. An amount of $P is invested at an annual rate of R% compounded annually, semi-annually, quarterly, monthly for T years. Okay, these are like the four cases. I'll make you understand. Let me first write the question, complete question. Find the interest earned after T years. Find the interest earned, or find, let's say find the amount, because in case of interest I'll again have to subtract the principal. So anyways, that thing you can also do. It's nothing new about it. Okay. An amount of $P is invested at an annual rate of R% compounded annually. There's going to be a comma after this. Compounded annually, semi-annually, quarterly, monthly for T years. Find the amount earned after T years. Okay, so these are like basically four questions in one question. Your money is either being compounded annually, or it is being compounded semi-annually, or it is being compounded quarterly, or it is being compounded monthly. An amount of $P is invested at an annual rate, that is an yearly rate of R%, compounded annually or semi-annually or quarterly or monthly for T years. Find the amount earned after T years. The only question that I have, for which I would expect you to have your answers ready, what do you mean by these four terms? What role would these four terms play? What do you mean by when you say that your money is being compounded annually? What do you mean by when you say that your money is being compounded semi-annually or compounded quarterly or compounded monthly? I don't want formulas. I want you guys to be ready with an answer, that is, what do you mean by these terms? You all would have read about this. You all would be knowing how to calculate. That's not a big deal. I'm not interested in formulas. I want you to understand these terms. What do you mean by when you say that your money is being compounded annually? Sorry. What do you mean by when you say that your money is being compounded semi-annually or quarterly or monthly. What do you mean by this? That's the important question. Now try and understand. I'll try to be as clear as possible and try to make you understand in the simplest way possible. When you say that your money is being compounded annually, when you say that your money is being compounded annually, irrespective what your rate of interest is, in like it's a annual rate of interest or monthly rate of interest, irrespective of the unit of rate of interest and irrespective of the unit of time period, if your money is being compounded annually, then this means that you're going to receive your interest after 1 year. That means you will receive your interest after 1 year. Like, or in other words, so to say that you will receive yearly interests. You will receive yearly interest. This is basically what it means. You will receive yearly interest. If your money is being compounded annually, that means you will receive yearly interest. If your money is being compounded semi-annually, again, irrespective of the rate of unit of rate of interest and unit of time period, if your money is being compounded semi-annually, that means you will receive your interest after every 6 months. This is the meaning. Similarly, if your money is being compounded quarterly, you basically have 4 quarters in 1 year. That means you will receive your interest after every 3 months. After every 3 months. And when you say that your money is being compounded monthly, that means you will receive your interest after every month. This is the meaning of the term compounded annually, compounded semi-annually, compounded quarterly, or compounded monthly. Now, what changes or what impact these terms are going to have on the formula? Now, if you have an annual rate, if you have an yearly rate or an annual rate, and your time period is also in years, and your time period is also in years, and your money is being compounded annually, then the amount received will be P into 1 plus R by 100 to the power t. Like, there will be no change in the formula. Why? Because you have an annual rate of interest, you're receiving your interest after t years, that is also in years, that is time period, and your compounding cycle is also in years. Nothing is going to change. Nothing is going to change. But when you talk about semi-annually, some things are going to change, and we're going to use our logic. We will not memorize anything. We're going to use our logic. Now, see, when you say that your money is being compounded semi-annually, that means you will receive your interest after 6 months. Which means, can I put it in this way? That means I'll be calculating interest after every 6 months. Because if I'm receiving my interest after 6 months, that means I need to calculate my interest after 6 months. Now understand, my rate of interest is an annual rate of interest. That is, it's an yearly rate of interest. But I need interest after 6 months. I need interest after 6 months. That R percent is for 12 months. That R percent is for 12 months. So for 6 months, my rate of interest will automatically become R by 2. For example, let's suppose if I say that the rate 10% is for 12 months. So for 6 months, it will be 5%. Simple maths. If rate is 10% for 12 months, so for 6 months, it will automatically become 5%. So if you have an annual rate of R percent, but your money is being compounded semi-annually, then your rate of interest will become R by 2 for those 6 months. That's the first change. Now, second change is in the time period. Now you have a time period which is in years. But you are receiving interest after every 6 months. Now in 1 year, you have 2 6-month cycle. In 1 year you have two 6-month cycle. In 1 year you have two 6-month cycle. So in T years you're gonna have two T cycles. In T years you're gonna have two T cycles. In T years you're gonna have two T cycles. Because you're receiving interest after 6 months, so in 1 year you'll be receiving interest twice. In T years you'll be receiving interest 2 times. Okay, so always remember that when you talk about this formula T, okay, I have mentioned in the previous video that this is basically the years, no denying on that part, but better remember this in the way that this basically represents your compounding cycles. This is more related to your compounding cycles. If your money is being compounded twice in 1 year, so in T years it will be compounded 2 times. So your compounding cycle is 2T. Next is when you talk about quarterly. So how many quarters do you have in a year? You have 4 quarters. Now again the rate of interest is R% per annum, but you need for 1 quarter. Okay, so let me just remove this. Now we all know what the question is. So we have basically 4 quarters. So what's going to happen to rate? Rate will be divided by 4. Because I need to divide that rate into 4 quarters equally. Because my money is being compounded 4 times in 1 year. I'll be receiving interest 4 times in 1 year. So R by 4 by 100, 1 plus, and in the power you're going to have 40. Because you'll be receiving interest 4 times in 1 year. So in T years you'll be receiving interest 40 times. And multiply this by P and this will become your amount. This will become your amount. And the last case, when your money is being compounded monthly, so that means you are receiving interest now after every year. Sorry, my mistake. You're receiving interest now after every month. In 1 year, how many months? 12 months. So in this case, it will become R by 12. The rate of interest will become R by 12. Divided by 100, you're going to add 1 to it to the power 12t. Now remember that you will only use these formulas. You will only make modification to these formulas when your compounding cycle is different. When your compounding cycle is different to the unit of rate of interest and time period. Let's suppose if the question was an amount of $P is invested at a monthly rate of R% compounded monthly for T months at a monthly rate of R%. Like what I mean to say is that instead of this annual, let's suppose if it was monthly rate of R% compounded also monthly for T months, then you will not use this formula. You will go by the basic formula. Because now your compounding cycle, your time period, your rate of interest, everything syncs. This is what you need to understand. Alright, I hope this is clear to everyone. So let's start with a question. Alright, pause the video and try this one. This is a question which is based on logic. Okay, so basically just discussing like whatever we have discussed, are you able to extrapolate on that one? Okay, so pause the video and try this question. Alright, let's see what we can do with this one. $H is deposited in 2 different accounts, one giving simple interest at an annual rate of K% and other giving compound interest at an annual rate of K%. So for the one which is giving simple interest, the principal value is $H, rate is K%. The one giving compound interest has a principal value of $H and a rate of K%. The final amount from the first account after 2 years was observed to be $P. Alright. The first account is giving us simple interest. So what you can simply do is, if you want, you can calculate the simple interest after 2 years. Will basically be H into K into 2 divided by 100. And since it says the final amount, so your amount will basically become H plus HK by 50. The bottom line is that the interest that you will be earning for 2 years will be HK by 50, or if you talk about per year's interest, that will be HK by 100. Okay, this is like per year's interest. So for 2 years it will be 2 into HK by 100, which is HK by 50. This is basically what it means. Now coming to the second part, that is the compound interest. Now it says that the final amount from the first account after 2 years was observed to be P, which we have already calculated. So this value is basically P. If in case you're wondering what is P, this is P. Okay. And from the second account after 1 year was observed to be $Q. So the one which is giving you compound interest will give you an amount of $Q after first year. Now I told you that when you talk about first year, the simple interest is always equal to compound interest, because when you talk about first year, we don't have any additional interest on which we can calculate compound interest. We simply have the principal value and that's it. We do not have any additional interest on which we can calculate the interest. So as far as the first year is concerned, the interest, the compound interest that we will be earning will be equal to HK by 100. It will be equal to HK by 100. It will be equal to HK by 100, which is, and if you're going to add H to it, because Q represents the amount, it's not the interest, Q represents the amount. So you can basically say that Q will be equal to H plus HK by 100. Q will be equal to H plus HK by 100. Now the third thing that I have to calculate is the value of R. Now before we go into that, let me do one thing. Let me like remove this. So P here is H plus HK by 50, and the interest for 1 year, or let me write interest per year, came out to be HK by 100. This was the case of simple interest. When we spoke regarding compound interest, the value of Q came out to be H plus HK by 100. That is basically the amount after first year. If I want to calculate the amount after 2 years, which is basically I need in order to calculate the R. Now what I can do is I can either use the formula for compound interest for 2 years directly, or what I can do is I can basically use this value of Q in order to calculate the interest for second year, and then add the first year's interest and then calculate the value of R. So it's completely your call which way you want to do it. Let's simply use the formula so that everyone is convenient. So the value of R will simply become principal, which is H, into 1 plus K by 100 square. This is the final amount. That is principal, which is H, into 1 plus rate of interest divided by 100 whole square. Or the value of R can also be written as H 1 plus K square by 100 plus 2K by 100, simply like opening this as A plus B whole square. Or the value of R is equal to H plus HK square by 100 plus HK by 50. This will become the value of R. So you can say that the value of R is basically greater than the value of P, which is basically greater than the value of Q, which is greater than the value of Q. Now let's suppose if question was something different, or if they would have asked you like compare the interest earned for in both the cases. The question was compare the interest earned in both the cases. Then what would have happened? Now when you talk about simple interest, the interest per year will automatically be HK by 100. There will be no change in it, whether it's for first year, whether it's for second year. But when you talk about compound interest, you will definitely have HK by 100 for the first year, that is the interest on principal. You will also have HK by 100 as the interest for second year also. But in case of second interest, you will also have K% of HK by 100, that is an additional interest. That is interest on first year's interest. So as far as first year is concerned, the simple interest and compound interest are equal. But for second year, the compound interest is greater than simple interest. Let's say in the question, if it was given to you that the simple interest earn for 1 year, let's suppose this value is given to you as some value L. Compound interest earned for first year, let's suppose this value is given to you as K, and the compound interest earned for the second year, let's suppose this value is given to you as M. So arrange L, K and M in the ascending order. So it will be M, the greatest, then it will be L and K, which will be equal. And it will be L and K, which will be equal. This is basically what you need to understand. Alright, let's move on. Okay, another thing which you need to understand. Now, sometimes what happens is, this is specifically these type of questions I have frankly seen in all the 3 exams, that is SAT, GMAT and GRE. What happens is, if you directly know the formula for exponential growth and decay, you can directly find out the answers. Like, you don't have to remember the entire process. So if you want to know like how do we calculate exponential growth and exponential decay, so when you talk about an exponential model, this is very closely related to compound interest. So when you talk about the exponential model, these type of questions I have frequently seen in SAT exam. They do come in sometimes in GMAT also, very rarely seen in GRE, but they can come, no doubt in that. Whenever you talk about an exponential model, any exponential model is given as where R naught, or you can have P naught, or you can have A naught. This basically tells you regarding the initial population. This Rn tells you regarding the population after n years. This 1 plus R is basically known as your growth factor. This is known as a growth factor. N there represents the time period. N there represents the time period. This is exactly like compound interest. But sometimes students are comfortable once I explain them the exponential model. They are sometimes a bit more convenient with this. So Rn is equal to R naught 1 plus R to the power n. Similarly, we have this is known as your growth model. Whenever you have an exponential growth, if you have a decay model, there is nothing much that changes. The only thing that changes is that when you talk about the decay model, in that case your formula becomes Rn is equal to R naught 1 minus R to the power n. This is the only change, because when you talk about decay, the population decreases. When you talk about growth, the population increases. That's what the difference is. Okay? Exactly the same. Rn again represents population after n years. R naught is the initial volume, 1 minus R is the decay factor, n is the time period. Okay, so we'll try to use these also while solving the question, so that you can relate the concept part with the theory part, sorry, the question part. Now, while linking with AP and GP, always remember that whenever you have your terms in arithmetic progression, and if you try to plot those terms in an xy plane, if you try to plot those terms in xy plane, or if you try to plot an arithmetic progression in an xy plane, like if you have a general term of arithmetic progression, for example, let me first remove this. Let's say you say that I have an arithmetic model that is a sub n is equal to a plus, let's suppose, 5d, or let me put it in a better way. We know that the general form of AP is a plus n minus 1 into d, for example, let's suppose. And I say that I have this expression that is, let's suppose, that represents the growth of bacteria, and that is given as 3 plus 2n. So this expression 3 plus 2n is basically an expression of arithmetic progression. That is, you keep on changing the value of n, because n is going to, let's suppose that n represents the time period here, and this 3 plus 2n basically represents the number of bacteria in million. So when you have n is equal to 0, you have 3 million bacteria. When you replace n by 1, you're going to have 5 million bacteria. When you're going to replace n by 2, you're going to have 7 million bacteria. You can see that basically the values are increasing in arithmetic progression. The values are increasing in arithmetic progression. So whenever you have terms in arithmetic progression, remember that. And if you're going to draw that graph on an xy plane, it will always come out to be a straight line. It will always come out to be a straight line, remember that. If it is an increasing AP, let's put it in this way, that this is linearly increasing, or it is an increasing AP. Increasing AP basically means that the positive difference, the common difference is positive. If it is an increasing AP, it's going to be an increasing line, a line that's going to have a positive slope. If you have a line something like this, then this basically means linearly decreasing. That is, you have a decreasing AP. That is, you have a negative common difference. If in case your terms are in GP, If in case your terms are in GP, then you get a curve. This represents exponentially increasing. When the common ratio is greater than 1. And if you have a graph something like this, then this basically means exponentially decreasing. That is mod of r is less than 1. That is mod of r is less than 1. So the two things that we discuss, that is the growth factor and the decay factor. This one represents the growth one. This will be the graph whenever you have a growth factor. If in case you have a decay factor, then this is what the graph of decay factors look like. If in case they ask you in the exam, they won't, but I just thought let me connect the dots for you. So two things that you need to remember, that is whenever you have your terms in GP, or if they are like exponentially increasing, then you have curves. If they are like arithmetically increasing, that is you have a positive common difference or a negative common difference, then the graph comes out to be a straight line. This is usually asked in SAT exam. I haven't seen any question on GMAT or GRE for this concept, but this is for sure asked in SAT exam, no doubt in that. Okay. Alright, let's move on to the questions now. There is no more theory part for us to discuss, not simply the questions. So pause the video and try this question, please. Alright, let's try this one. Now you can solve this question with the help of logic also. Like if you don't want to use the formulas and everything, we can make use of our logic also. Anyways, it says that the population of a locust in a certain swarm doubles every 2 hours. So you can see that you have a growth factor of doubling. This is your growth factor. You can say that your 1 plus r is equal to 2. If 4 hours ago there were 1000 locusts in the swarm, in approximately how many hours will the swarm population exceed 250,000 locusts? So we are looking at a final population of 250,000. We're going to start with 1000 and we're going to first find out the time, that if they have a growth factor of 2, then after how many hours they will become 250,000. So this will give me that 250,000 is equal to 1000 2 to the power t, or 2 to the power. So 30 goes, 30 goes. So 250 is 2 to the power t. Now I can do it in this way, that I know that 2 to the power 1 is 2, 2 square is 4, I know that 2 to the power 6 is 64, then I just need couple of more. 2 to the power 7 is 128, 2 to the power 8 is 264. So I know that I need a value of t to be like approximately 8. It will be something less than 8, but it will be approximately 8. So if you start with 1000, locusts, then in 8 hours, if you are doubling them every 2 hours, you will reach a value of 250,000. If you're starting with 1000, then in approximately 8 hours, if you have a growth factor of 2, you'll have a locust population of 250,000. But that's not the question. It says that if 4 hours ago there were 1000 locusts, in approximately how many hours the swarm population exceeds 250,000 locusts. So you have to subtract 4 hours from the total time period of 8 hours. That means in approximately 4 hours from now, because this 1000 basically was 4 hours ago. This 1000 was 4 hours ago. So that is approximately 4 hours. You'll have a swarm population that exceeds 250,000 locusts. That will exceed 250,000 locusts. That's the question. Alright, let's continue to the next question. Pause the video and try this one, please. It's a simple question. I just want you guys to be through with that concept of growth and decay. So try this one, please. Alright, a certain type of ant community has a population of 2 million. The population of ant community grows in the exponential model p is equal to 2 million 1.004 to the power t, where t is in years. What is the growth rate of population? What is the growth rate of this population? They are asking us for to calculate the rate. Okay. Now I gave you this formula that Pn is equal to P naught 1 plus R to the power n. And I told you that this value 1 plus R basically represents your growth factor. It represents your growth factor. And this R here is basically your growth rate or your decay rate, depending upon whether you have a positive sign or a negative sign. So this is the growth rate in percentages. So let's compare this value with this one. So I can say that P is like 2 triple 1.004 to the power t, which now I'm not gonna write this 2 million again and again. There's no point on that. So I'm simply be talking about this value here. So this will basically become 1 plus 0.004 to the power t. But I need that growth rate. I need that growth rate. So I need to convert this into percentages. So if I have an absolute value and if I want to convert this into percentages, I'll have to multiply it by 100%. It will be 0.004 into 100%. So this will basically become 0.4%. So the growth rate of this ant community, the growth rate of this ant community is 0.4%. The growth rate of this ant community is 0.4%. Alright, that's your answer. If the question was find out the growth factor, then it's 1.004. If it's growth rate, then the growth rate is 0.4%. That means for every year, or basically let's put it in this way, that the ant community is increasing by 0.4% for whatever time period it is. It's given in years, so let's say that in 1 year it's growing by 0.4%. This is basically what it means down the line. Okay, so this is how you interpret 1 plus R to the power n. Alright then guys, let's keep it till here as far as this video is concerned. We have also understood like couple of theory points in this, then we have solved questions also based upon that. If you have any concern, if you have any doubt in the theory that I have taught you in this video, then you can drop in a comment. You can also ask me over WhatsApp or you can mail me also. And please don't forget to subscribe to the channel, like the video, share it among with your friends. And if you're looking for any personalized classes for SAT, GRE or GMAT, you can always connect with me. So thank you so much guys for watching these videos. Thank you for your wonderful comment, and keep watching and keep learning. Thank you so much. Till next time.